Hello, everyone. Let's get started. So the topic today is enabling scale with certified 3D printers and materials. Um, and we are also going to talk about the next generation of FFF 3D printing with RIZE. And the reason why we are able to create this generation of 3D the certified printers and materials is part of the innovations we do. So the first few slides, I'm going to talk about the innovations at RIZE, the augmented polymer deposition and such, and then we will get to the certification process, UL certified 3D printers and materials, and then we go from there. Okay. Um, so at RIZE, the foundation of everything we do is based on a patented innovation we did at RIZE called augmented polymer deposition, which is what you see here. In the augmented polymer deposition process, the way it works is you have material extrusion. Basically, this is where the material is extruded. This is a proprietary material from RIZE. And then you have material jetting, and the jetting is done using what we call functional inks. And we call them functional inks because each one serves a purpose, and I will explain that as we go forward as well. And the way it works is you have, whenever you 3D print a part, you have a physical part, you have supports, and one of the functional ink we have is a release ink. And we put a release ink in between the support and the part, which allows for easy support removal. There are many advantages to it. We will talk about that as well. And also we use colors. One of the colors we use is a marking ink, which allows you to put logos, part numbers, and such, as well as we have CMYK inks, and these are controlled at the voxel level. So these are absorbed into the part at the voxel level control, and we will talk a little bit more about that as well. So there's a lot of innovation that we have done at RIZE with respect to the print process, and that is what we call augmented polymer deposition or augmented deposition technology. So very quickly, in the last 2 months, we recently released a brand new product called RIZE. I just want to give you a quick look into it. This is the RIZE 3D printer. Here, this is what you see, where you have the APD process in the carriage. Using it, this is made for ease of use. Basically, anyone can use it. You don't need to be an expert user at all. Novices and experts alike can use this printer very well, and it prints in full color. Here you are seeing a living heart. This is a cross section of a heart, easy support removal. So you can create some very thin surface, very thin parts and things like that. So anyways, I just wanted to give you a quick view. And what happens is, along with this, users are able to put QR codes for digital traceability. We will talk a little bit more as we move forward. As I said, part of the certified 3D printers and materials is enabled by our process innovation as well as the material science innovation. On the process innovation, I already explained to you about the material extrusion and the functional jetting, creating beautiful parts like what you see here of a heart. The inks are functional inks, so you have release inks that allow for easy support removal. You can mark the parts and you can do it in full color. The material science innovation, our materials are based off cycloolefin based. These create with some very high industrial strength and durable parts. But one of the things this RIZE, which is cycloolefin based material, does, it has zero emissions, recyclability, and zero waste. And also this material is USP Class 6 medical grade certified, and I will explain that a bit more as we move forward. Okay. So part of the reason why you get this certification for the printer and the certification for the material is the innovation we have done on the process, innovation we have done on the material science that gives you some of these advantages. Okay. Now, Very quickly, traditional FFF process compared to augmented polymer deposition. This is fairly new, so we don't have the range of materials that typical FDM printers or FFF printers have. This is a ever expanding portfolio. We are going to release the glass fill fairly soon, but this is one area where I think more work needs to be done. However, with this augmented polymer deposition technology, you have no harmful emissions, very high moisture resistance, so the material barely absorbs any moisture at all. You get some, because of the process innovation, your Z strength on the part is 95% of X and Y. The RIZE 1 3D printer is actually UL 2904 certified. So this is by the Underwriter Laboratories. I will explain a little bit more what that is as we move forward. And also the material has USP Classic certification. It's medical grade. I will explain that as we move forward as well. The post-processing, zero toxicity. Most parts people remove supports under 2 to 5 minutes. So it's not labor intensive at all. And you get functional surfaces when you remove the supports. And I will explain that again as we move forward. Many customers have bought our RIZE 1 3D printer because of the trust. In fact, there's a medical company that recently purchased RIZE because they failed an audit. And the reason they purchased RIZE is because now on the parts you can put part numbers, QR codes that give you trust and traceability. Likewise, you get full IP protection because of the way we put marking on the part, and with full color as well. And that is something our augmented polymer deposition will bring to you. So very quickly, let's go to traditional process compared to FDM. You see here on the left-hand side how the supports are removed with RIZE. What happens is the release ink is something like a mold release agent. It's something that goes in between the support and the part. So to remove that, it's very simple. For areas that are hard to reach, you use plier or something, and you can see how easily the supports come out and the part is done, right? So compared to water-soluble supports and such, you get very high fidelity surfaces, excellent surface finish. So one of the things that's important is that once you remove the supports, basically you don't have to do any post work, and it keeps the tolerances, and you get functional surfaces right after you remove the supports. Let's take another example. Here you have a fairly large surface touching the raft, and you see how easy it is to remove because of the release agent we put between the support and the part. There you go. That's how easy it is to remove the supports, and that's done. And you can see another example, very complex surfaces. There you go. How easy it is to remove the supports again. Done. We recently had another medical customer in the life sciences industry purchase RIZE purely because of how easy it is. They were able to remove supports on their models. We did some benchmarking, and the fidelity of the surfaces that come out once you remove the supports. Okay. And you can see again on the left-hand side, this is the third part where the supports are being removed, and the part is ready to be put into function. So I don't want to spend too much time explaining this. So that's one of the values of augmented polymer deposition. The second thing is intelligent parts. The minute you put a QR code that is at a voxel level, that's absorbed into the part, you can scratch it off. You can do some very beautiful things. Number one, you can connect it back to the PDM, PLM systems that you have. And when you scan it, you can pull in the part information. For example, you can bring in things like who manufactured it, what assembly does this belong to, when does this part expire, and if you need to reprint the part, you just scan the QR code, you retrieve the correct part, and you can go 3D print it. So this gives you traceability, it gives you trust, and many customers take full advantage of it of RIZE. Another example is, in this case, you are seeing e-drawings from SolidWorks. You can actually scan the QR codes and now open the full assembly, and you can see augmented reality, virtual reality of the part. Um, we have customers, when you scan it, you get assembly instructions that come on this, how to assemble this part in the context of the larger assembly. And then finally, if you have a supply chain and you want to actually print trusted parts with trusted materials, you just scan this QR code and it goes to your internal marketplaces. And basically now you can actually know who printed it, how many parts were printed, what material it was printed in, and all that stuff. So now your 3D printed part is intelligent, it's live, it actually gives you a lot of good information that is necessary for you to trace it and for you to trust this particular part. And finally, with augmented polymer deposition, we can now print the same functional parts in full color. Vivid colors, you can do some very complex geometries and such. And our customers are doing some very interesting applications. I will talk about that towards the end of the presentation. So why safety matters? Underwriter Laboratories and Georgia Institute of Technology have done quite a bit of research, and they published a paper. It's called Characterization of Volatile Organic Compound Emissions from Consumer Level Material Extrusion 3D Printers. And basically, they have tested different kinds of materials, and they released a very important paper that I believe that everybody in this industry should read. And some key takeaways. Some of the key takeaways are 90% of the particles emitted by the 3D printers they tested are in the nanoparticle range, less than 0.1 micron, and when inhaled can cause cardiovascular and pulmonary issues. They also detected 200 plus volatile organic compounds, and many of them are known irritant and carcinogens. For example, formaldehyde is a known carcinogen. Styrene, it's a flammable chemical and irritant. Caprolactam, known irritant for eyes, throats, and headaches, and many others. And basically, what happens is when you melt these polymers and when you extrude it, these are being emitted out of the 3D printer. And there are some short-term and long-term effects. We will skip that for now. This is again from their research paper when they tested ABS, PLA, nylon, high-impact polystyrene, and PVA. You are getting all these emissions like styrenes, formaldehydes, and you can see what different materials are emitting out there. When 3D printing originally started, this was for industrial use with good venting processes, with experts using these particular printers. As patents expired, now you have 3D printers everywhere. They are sitting next to you. And I don't believe people are giving enough thought to the safety aspects of the printers as well as the materials they are printing. From an OSHA standpoint, the printer might be okay. It's not going to fall or hurt or anything like that. But these are the emissions that are coming out of the 3D printer. And basically, some of the things, again, on the consumer level, what they tested was, again, these are not industrial setup 3D printers with exhaust. These are consumer which could sit next to you. Is that most FFF 3D printers emitted high levels of VOCs. One of their very interesting findings was HEPA filters themselves did not reduce VOCs considerably. And they say that 3D printer certification is recommended to quantify the associated risks. We are very happy to announce that we actually work with Underwriter Laboratories. UL has actually created a new standard called UL 2904. We are the world's first 3D printer that actually got certified for safety. Basically, it's a system level certification, which means the RIZE 1 3D printer, the Rizium filament, the filament in this case is Rizium, that was tested, the marking and release inks, these are the inks that are in this particular printer for marking purposes and to remove the supports. They met or exceeded the certification requirements to receive the certification for UL Green Guard. And so when we ship these printers, we actually proudly put the UL Green Guard certification on top of it. What does it mean to you? It means that it assures you about safety. And some companies are looking for sustainability goal in LEED certification. This will help you that. Also, this material is recyclable, so there is no waste, and more importantly, peace of mind. And for employers, potential future liability, they are safe from that. I'll give you another example. One of our customers here in Boston, they run a big additive lab, fairly large company actually, and the additive lab manager told us he is most comfortable using RIZE because he knows 20 years from now there is very low risk of any health impact. The word he used was cancer. 20 years from now, he will not be impacted by anything negative from a health standpoint. That's very important. And this is a gentleman who knows 3D printing very well. He has a fairly large range of machines in the additive lab, and they are servicing quite a bit of innovation that happens inside their company. Another example, a university in Boston has banned print ABS anywhere on campus because they were worried about health risks posed by emissions from printing ABS, right? We have a medical customer in life sciences. When you go visit their lab, every 3D printer, doesn't matter what technology, they have a negative suction hood sitting on top of the 3D printer. The only one with no suction or anything, with no ventilation is RIZE, because they have done their internal testing for the last year and a half, and they found RIZE not to consider any emissions at all, in their words. So this is important. And what you get from RIZE is obviously very strong parts, stronger than ABS, stronger than PLA, and with very good Z strength because of process and material innovation. And because of augmented polymer deposition, you saw how easy it is to remove supports. And in addition to all of this, it's a safe printer that has no emissions coming out of this the printer, or at least UL 2904 certified 3D printer. So we are proud to say we are the world's first UL 2904 Green Guard certified with zero toxic chemicals, safe markings, and the material is also USP Class 6 certified. I will talk about that, and zero emissions. Okay. So now when you buy RIZE 1, you get a certified UL certified 3D printer. You wouldn't put a light bulb in your office that's not UL certified. We believe it should be the same with 3D printing as well. And in fact, if you buy some other printer, that needs to be UL certified as well. Now, our material also, again, as I said, it's cycloolefin based, and it has received USP Class 6 certification. So the base material you buy from RIZE is USP Class 6 certification. In other words, the material is non-toxic, it is biocompatible, and medical grade. And what does it mean? USP Class 6 is the most stringent and the most comprehensive certification you can receive for materials. The kind of testing they do is for oral, in other words, in the mouth, inhalation through the respiratory system, as well as acute toxicity, as well as implantation. So the RIZE parts can be implanted for a short period of time into the human body with no negative effect at all on you. So number one, the print process system level is certified by UL 2904. This is RIZE 1. And the material that is used is actually biocompatible. In other words, when you handle it, when people use it, when students use it, it doesn't matter. It has zero negative effect on touch or anything like that. So it's a strong material. In addition, you get the certified material as well as the certified printers. The other thing, what we are doing with respect to augmented polymer deposition is to give you an entire digitally connected experience. In other words, you can do things like generative shapes, and on top of the shape, you can put your QR codes, obviously. You can get the haptic experience because generative shapes are very difficult to understand. And so now you can touch it and feel it. And then finally, by QR code scanning the part, now you're connected back to the digital. So now you can go from the digital part to the physical part and back to the digital. So even after 5 years, you can take this part, you can QR code scan it, and you know precisely who made it, what version of the part it is, which product does it belong to, and you can get all the intelligent and valuable information you can get out of this particular part that you print. Okay. Some of the things our customers are doing with RIZE, very interesting stuff. We have customers using RIZE 1 3D printers for conceptual design. Um, we have customers doing for design iterations. This is one of our customer where in the night before they go home, they actually put multiple versions of the part on the print bed, and they actually mark it each one and put part numbers. So in the morning, you can actually visually tell which one is what, and they go functionally test it, prove it out, and then so that's how they are doing their innovation or speeding up their innovation. We have customers printing simulation with our XRIZE product. One of the very interesting applications I'm seeing people do is actually 3D print the part along with the drawings, because drawings are hard to read and people really don't understand drawings well anymore. And now when they send the 3D printed parts in color, where different datum surfaces are in different colors, similar holes in the same color, critical surfaces for tolerances in different color, they are using that for speeding up the design to manufacturing and reducing manufacturing errors. We have customers that are doing quality and inspection. Tooling jigs and fixtures, one of the materials you can print is carbon composite on the same printer. So you can do tooling jigs and fixtures. Customers are doing end-use parts, and they're also doing service MRO. And net, what we are seeing is customers are driving innovation. One customer told us that they have actually compressed a design cycle. It's from 2 days to 4 hours because of RIZE and how fast they can actually 3D print it, remove supports, functionally test it, and go back to design change. We have customers telling us they are compressing time to market by as much as 3 weeks per product and reduce parts costs. This is a service MRO case where they were able to reduce 90% cost compared to traditional manufacturing on a one-off component. Okay. How does it work? Here's an example of SolidWorks. This is an end-to-end process. You can open SolidWorks, and then we have an add-in where with one click, it actually goes to RIZE One Touch. RIZE One Touch is a software where you can slice it, add marking and things like that. Inside SolidWorks, if you put the colors, if you actually put the labels and everything, you can take a VRML or an OBJ or a 3MF file into our One Touch, and you don't have to do anything else. In this case, this part doesn't have any branding or logo, so you can now come into our One Touch software. You drag and drop the logo. It conforms to the geometry. And then what you can do is you can go to the top. In this case, we want to put a QR code, so we will just align the part to a certain orientation. You go to the QR code, select which one, who, what, and how. Click OK. You just drag it, drop it in place, and that's it. Now the part is ready to be printed with your logo and the QR code ready to go. At this point, you just center it to the bed, and you're ready to print. So you go to Prepare Job and hit Send. So it automatically generates the supports. It automatically creates locations where it has to put the release ink. You don't have to do anything. And here is the RIZE One printer that's UL certified. It's a magnetic build plate. The build plate comes leveled from the factory. You don't have to ever do it. It's extremely easy to use. You can print from the cloud, or you can come to the machine, select which part you want to print, and hit the print button. It's a heated chamber, so you get very high consistency, high tolerance parts from the printer. There are some patented technologies that automatically level measures for the bed area and compensates for it up to a certain extent. And after that, it's ready to print. On the top, you saw the augmented polymer deposition. It's a whole tray that has both extrusion and inkjetting in one. And you know, the part, as you can see, is printed vertically up, just like in FFF 3D printer. Once it is done, it's a fairly straightforward process. You just take it out and really remove the supports and go from there. Okay. So there you go. The part in real life, it's not this fast. This is a 2.5 hour or 2 hour job, by the way. It's accelerated and sped up. And now you just scrape it off the bed, and removing supports. It's that simple, as you can see. There you go. 2 and 3. Remove the areas. That's done. And once it's done, now you can go to your iPhone camera or a QR code reader on any camera, select it, and there's the part information that we put on the QR code. Okay. So I hope that explains our end-to-end process. Anyone can use it. We have RIZE 1 3D printer on the manufacturing floor. A CNC user is using RIZE as easy as any other machine. We have it inside engineering offices. And all kinds of profiles, customer profiles use this particular printer. So essentially, with RIZE portfolio, what you have is safe systems. So the printer that's certified is RIZE 1 that you see right here. RIZE is something that we just released in the last month. We will send this for UL certification as well. Safe materials, Rizium is again USP Class 6 certified. Our Rizium carbon composite material, we launched it last year. So now on these two machines, you can print Rizium as well as Rizium composite. We have RIZE One Touch. This is a slicer. RIZE Connect, it's in beta. This is one where you can actually, send a print anywhere in the world to any printer that's connected via the cloud. And you don't even need to have a user at the printer, because once it knows that the print bed is empty, it actually kicks off the print on its own and actually notifies you throughout the print process what stage it is and when it is done via email, via SMS, and things like that. And savings, as I said, the RIZE One print process, which you are seeing these two images, the release ink and marking ink is part of the safety certification. The CMYK, which is color, which goes with RIZE, we will get it certified soon as well. These are all based on the same technology and material science. So with that, thank you very much for joining this presentation.